All right, so our skill packet 5 was exponential functions and log functions. In our most recent test, let's go over these problems. Now, before we do that, let's talk a little bit about the graphs. If we have, from our library of functions, if we have a basic exponential b to the x, what should we know about the general shape of this graph? The general shape, oops, I started drawing a logarithm. Um, looks like this if the base is greater than 1. And it'll have a y-intercept of 1. It will have a horizontal axis of y equals 0. The domain of any exponential function, even if you make any transformations of shifts left, right, up, down, any reflections, um, is all real numbers. And for this basic exponential function, the range is positive real numbers. And you'll notice that the 0 in the horizontal axis appears, that 0 appears there in the range, and that'll always be the case that they appear. Now, this range is where the domain is going to remain, is always going to be all real numbers for any exponential function, no matter what the transformations are. The range is dependent upon, the transformations on y. So we do need to be aware of that. Now, if there's a transformation on x, if there's a reflection, then that's going to reflect across the y-axis, or it could be written with a base that's less than 1. So let's quickly talk about that real quick. That if we have some function that's an exponential function where the exponent, the variable's in the exponent, and the base is less than 1, and of course all the bases are positive. Um, so between 0 and 1, if it's a proper fraction, then it's going to be a decreasing function. So it's going to look like this. The y-intercept is still 1. So I'm trying drawing it freehand. It's kind of sloppy. It's a reflection across the y-axis is what it is. The domain, as we said, for any exponential, no matter what the transformations are, is all real numbers. And the range here for this one is 0 to infinity. But if we have a negative sign in front of there, or if we're adding something different than 0, or if we have a multiplier in front of there, well, not the multiplier, this shifting up and down, or a reflection, is going to possibly change the range. We have, again, a horizontal asymptote of the x-axis, but the x-axis, written as an equation, is the line y equals 0. When you give your asymptotes, it has to be in the form of an equation and not just a number 0. All right, so let's see if I had, yeah, here we go. Let's do these problems 1 and 2 on the same video. So we have an exponential function. For any exponential function, the domain is always all real numbers. For this exponential function, the base is bigger than 1. And we are not adding or subtracting anything to this, so there's no transformation up or down. So the basic graph of this is going to be like this. The range, because that's 0 there, we haven't lifted it up or not, up or down, up or down. Positive real numbers. The asymptote is horizontal. Not if it's vertical, it'll be x equals. If it's horizontal, it's y equals. And you'll see that number appear in the range, even if there's a reflection across the x-axis. The 0 will either be first or second, depending upon that. As x is approaching negative infinity, meaning as you are far to the left from the origin, These y values are getting closer and closer to 0, and when you're far to the right, when x is approaching positive infinity, the y values are going up without bound, up towards positive infinity. There is no x-intercept, so it does not apply. This graph is never going to cross the x-axis. To find the y-intercept, we let x equal 0, so we input 0 into the function, and by definition 4 to the 0 is equal to 1. Now I don't care if you write y equals 1 or 0 comma 1 or just a 1 there, but for the asymptote it has to be equation because this is representing infinitely many points. It's a line, whereas this is just the coordinate of a point. Alright, so that's for problem 1. Let's take a look now at problem 2 because it's similar. This time it's a log function. Maybe real quick I talked about the basic exponential function graph, but I don't think I talked about the log graph. If I have let's use function notation. If I have some function of a log with some base, and again the restriction on the base is it's a positive base, that it's not equal to 1. And of some value x, that this graph looks something like this. Logarithms and exponentials are inverses of each other, so a log is just a reflection across the line y equals x of an exponential. So remember, for inverses you switch the domain and range, you switch x and y. So what used to be for an exponential function a horizontal asymptote of y equals 0, it's now a vertical asymptote of x equals 0 because x and y switched. And what used to be a y-intercept of 1 is now an x-intercept of 1. The domain of an exponential function was all real numbers, but domain and range have switched. So now it's the range that's all real numbers. The domain of a basic exponential, or excuse me, the range of a basic exponential was positive real numbers, and with domain and range being switched, the domain of a logarithm is now positive real numbers. Okay, so that's stuff that we know, before we ever look at any of these problems. So if we take a look at this second problem, the range for any logarithmic function is all real numbers. And now for the domain, we do have a shift to the left and to the right. So without any shifts to left or right, I know my domain is 0 to infinity. Now this minus 2, which it's bizarre in its behavior, transformations on the x kind of act counterintuitive. You're not going to subtract 2 values from x, you're going to add 2 values. So the domain is actually 2 to infinity, and so your graph has been shifted over to where it's like this, and and then it's been lifted up 1. But lifting it up 1 is not going to change the domain. This is the vertical asymptote x equals 2, and see again, the number that we see here is the number that we see in the domain, just as the number that we saw for the horizontal asymptote was the number we saw in the range. The vertical asymptote is going to be the number we see in the domain. If there had been a reflection, then maybe it would be negative infinity to that number, but there wasn't. Alright, to find the x-intercept, we let y equal 0. For the y-intercept, we can see that this graph doesn't cross the y-axis at all. If the shift had been to the left, then yes, it would have crossed the y-axis. But in this case, your basic log function or any log function that has been shifted to the right is not going to cross the y-axis. For the x-intercept, we let y equal 0. So the y is the output of the function. In function notation, it's the f of x. And if we solve this equation for x, we'll have the x-intercept. So to get x by itself, on the right hand side I see two terms. The term of interest is that first term. I'm going to subtract 1 from each side. And that's as far as I can go here with this in logarithmic form, but I can change this log form to exponential form. The base is 3. A logarithm equals an exponent, so that's 3 to the negative 1 is equal to x minus 2. Well, 3 to the negative 1 is just 1/3. And then if we add 2, but I'm going to write 2 as 6 divided by 3, so I'm getting an x-intercept of 7/3. Alright, so I hope that helps on the first two. It's very much dependent upon, do you know the graph of the basic exponential function, the graph of the basic log function? Are you familiar with the transformations that I think it was Skill Packet 4 that we looked at? Hope that helps, and I'll talk to you later.